Welcome back to my channel, YouTube viewers. The day has come for me to refine a batch of gold-filled scrap as I sort through the material that my wife finds for me. I set aside the gold-filled stuff and I accumulate it until I've got enough to do a batch of gold-filled scrap. So what we're going to do is we're going to take a look at this stuff, see what we got. We're going to clean it up mechanically. What I mean is we're going to remove all the steel stuff out of there, any springs or stuff like that that's non-gold filled material. Then we're going to dissolve it in acid. I'm going to take the base metals underneath the gold filled coating and dissolve all that out. Then we'll recover that karat gold coating and refine it into pure metal, and then we're going to add it to our flask and continue our stacking of pure gold. Okay, here we go. We're going to do that right now. For the benefit of new subscribers, what I'd like to do is review here a little bit what we're going to be doing. I primarily deal with three types of scrap. Karat scrap is what I mostly end up refining because it has the highest yields, up around 50–60%. The next most prevalent is the gold-filled scrap, and that's what we'll be refining today. Gold-filled scrap usually yields around 2.5 to 3%. And then there's gold-plated scrap, and the yield on this is like 0.00005%. It's very low. It's almost nothing. Gold-plated jewelry has a very thin coating of gold, just a few nanometers thick. And it takes about 10 pounds of it just to get 1 gram of pure gold. So the process we're going to be talking about today is applicable to gold-filled scrap only. The process that we're going to use will not work for karat scrap, and it will not work for gold-plated scrap. What is gold-filled material? If you look down here, this is Hoke's book, and she explains what a piece of gold-filled material is. It's a block of base metal such as brass or copper, and to it they bond a piece of karat gold, and then they heat it up and run it through rollers, and then they use this material to make jewelry with. So this is the material that we're going to be working with today, gold-filled scrap. We're going to be cleaning it up, and then we're going to dissolve out this middle layer of brass and copper and recover the gold, the karat gold foils. They'll get left behind, and then we'll refine it with aqua regia. All right, here is our accumulated batch of gold-filled material. I'm going to throw it up here on the scale and give it a weight right quick. And that's 1,862 grams of gold-filled scrap. 1,862 grams. Now what we'll do is the same thing with the container I've got here. This has got, the container weighs 89.3. And like I said, what I do is I accumulate this, and as I'm going through the stuff that my wife finds for me, and I just throw it aside until I get enough to refine a batch. And then I think it's the last time I did this was back in last summer sometime, maybe August or July. So this is about 9 months worth of accumulation of gold-filled material. With the containers, I subtracted out the plastic container, but we've got 2,191 grams of gold filled material in here. And so now what we're going to do is we're going to take this and dump it all out here. All dumped out on my piece of cardboard here. And what I'm going to do now is go through and remove all the stones, all the springs, all the steel pieces, the leather bands such as this. And I'm going to get this all cleaned up mechanically. And then we'll incinerate the material after I get it cleaned up. And put it in some acid and dissolve out all the base metals. I start by picking out all the stuff that's already cleaned up and ready to go into the acids. This is a gold-filled watch case. Right down here it says 25 years. What that means is this watch is warranted from wearing through to the base metal, which is probably brass, for 25 years. But as you can see, it's got a little steel pin up here that operates the movement. So what I'm doing here is I'm going to peel off the gold filled material that's on the crown there. And the material underneath this, that's the good part right there. And this piece underneath of it is just steel. And if you look in there, you'll see there's a piece of steel right here. Got to get that out. That's no good. Throw that away. And then there's another piece of steel inside the watch. This stuff right here. Got to get all that out of there. I'm making some nice progress on this. This is all the material that I've got cleaned up and ready to go in acid. Okay, very quickly, I've got a piece here that I wasn't sure about whether or not it was gold filled. And if you, well, let me do this piece first. This is a piece of gold plated material, and I'm going to put a little bit of 14K gold testing acid on it, and watch what happens here. As soon as I apply this drop of acid, it immediately eats through that micro thin layer of gold plating down into the base metal, which is probably brass because that's green. And you can see it just ate the gold plating right off immediately. On this piece though, what we've got is I think this is gold filled, and the way we can test this is just take a little drop of this testing solution here and apply it directly to the piece. And as you can see, it just sits there and does nothing. It doesn't react. That's because there's a thick coating of karat gold over the brass that prevents the acid from getting to the brass. The gold testing solution won't eat away the thick coating of gold that's over the top of this piece. Now if you watch here, I'm going to take a file and rub a little bit of this off to get down underneath the gold filled covering. We'll put the acid on there, and boom, it turns green right away. And that's how we can tell if we've got a piece of gold filled material or not. When we put the acid on there and it doesn't eat through immediately, then we can pretty much conclude that we've got a piece of gold filled material. You can see a definite difference between the brass substrate or base metal as opposed to the gold filled, thick gold filled material on top of the brass. So this piece is in fact gold filled. I'm gonna put it in my gold filled bin over here. This piece is gold plated, so I'm gonna throw it down here in my gold plated scrap. All right, I just wanted to say one more time that it's important to not get any gold-plated material mixed in with your gold-filled material, because if you do, what will happen is the gold-plated stuff is so thin that you won't get any gold off of it, and you got a high likelihood that you're going to end up putting some junk in your batch here with the gold-plated stuff that is not, or is going to form compounds that will create problems in the process. So this process will not work for gold-plated material. Or yeah, gold-plated material. Gold-plated material is done separately, and I'll be making a video of gold-filled scrap, or gold-plated scrap, coming up. These things here, these are for pocket watches, and I save those. People buy those, so what I'll do is I'll cut this off of here and save that, and I'll be doing a video on gold-plated scrap, because the process for getting the gold off of gold-plated scrap is totally different than what we use for gold-filled stuff. This is all gold-plated scrap, and I'll be running it through a sulfuric acid stripping cell in a future video. The process that I'm applying for this gold-filled scrap will not work for gold-plated stuff. Totally different process. These are those gold-filled tops I was talking about, and it's just, you got to pull them off one at a time. It goes okay once you get the hang of it. I've got a pretty good start on separating our metal, and I think what I'm going to do here is put some of it up here into my ultrasonic cleaner and get some of the junk off of there before I go to the torch and burn this off. This should help. So we're going to put this in the ultrasonic cleaner and fire that thing up. Allow this to clean in the ultrasonic cleaner for about 10 minutes. We'll rinse it off real good with some tap water here. And then I'll give it a quick steaming. And then we'll set this aside and go to the next group. This is my steamer here. Alright, here's our clean metal, and what we'll do is save this. It's ready to be incinerated and ready for the acids. Alright, this is going to go in a temporary container here. This is all ready to be incinerated. I'm going to add another group of dirty gold-filled stuff here and put it in the cleaner. And this will just help get rid of some of the dirt and junk in there. Keep it out of our reaction. I just got to include this in the video here. This is my electrolytic silver cell. Up here is the anode filter basket. We put impure shot in here, and then we pass an electric current through it. That's the impure shot. And then I've got an electrode bar here that I've made out of silver, and I connect my power supply to it, and we run an electric current through the silver shot. What that does is that causes the silver in here to dissolve, and then it passes through an electrolyte in here that's made out of silver nitrate. And as you can see in there, we've got some beautiful pure elemental silver crystals growing in our silver cell there. And this thing runs 24/7, even when I'm sleeping. This thing is cranking out pure silver for me. So I just wanted to include that. Everything's been in the ultrasonic cleaner now, cleaning. And I've had it underneath this blow dryer now for about an hour. So it's all dried off. All right, zero this out. Now let's get a weight on our cleaned material. It's been through the ultrasonic. I've got all the non-gold filled material removed from here. All the springs, all the stones. And now what we should have here is just nice, clean, gold filled material. Looks like we got 1,272.1 grams. Made a quick note. We've got 1,272.1 grams. And what we should be yielding here is about 1,272.1 times 0.025. Should have about 31.8 grams of pure gold when we get done. Here's our gold filled scrap. What I want to do now is I'm going to put some distilled water in this beaker, fill it up to about 1 liter level. Distilled water going in. We're going to start burning this material a little bit at a time, and then we're going to add it to our beaker up here. Here we go. We've cleaned it up pretty good in the ultrasonic, but I want to go ahead and incinerate it also. Notice there's smoke coming off of there. And I heat this up just until it quits smoking. Well, we've got it all burnt off so it doesn't smoke anymore. I'm going to add it to the water here in this beaker. And then we'll do another group. Burning the material like this removes combustible material that we don't want going into our beaker. All right, here we go. We're going to add this group in with the stuff up here in the beaker. And then we're going to go for another one. I heat it to a dull red. I don't want to melt the material because it'll tend to alloy. This group into our beaker up here. It's getting pretty crowded in there. This is the biggest batch of gold filled scrap that I've ever attempted to do. Okay, coming up here in a minute is an example of why it's important to wear protective equipment, including protective eyewear. You'll see here in just a second, I'll experience an explosion in that dish. Not a big one, but enough to make me jump. That'll wake you up. That pop was much louder in person than came through on the recording on the camera there. And what happened was some of these pieces of jewelry will have cavities in them that are sealed up, and when we go to heat it up, it expands and then releases all at once explosively like it just did there. Alright, here we go. We're going to be bold. We're going to add this to the beaker as well. Like I said, it gets pretty crowded in there. I'm going to add a little bit more water to make sure that when we start adding the acid, that we've got some medium in there for the water or the metals to dissolve into. One of the gold-filled bracelets had this hinge in it, and it's heavy, and I think that metal right there is lead, so I removed this piece. We don't want lead in our group of gold-filled stuff here. Next step here is to start slowly adding some nitric acid. Put the heat on low. If you look up here, I've got a rig set up here that is a separatory funnel. And I've got a lead coming down, going into our beaker. Okay, now what we're going to do is add some nitric acid to our funnel. Make sure our stopcock is shut. I'm going to put 500 milliliters of nitric acid into this funnel. Here I'm adding a piece of damp paper towel to keep junk out of there and to keep the fumes in the funnel. Okay, now we're going to turn the flow on here. Carefully start adding nitric acid slowly to our gold-filled scrap in this beaker. And here we go. Go. Alright, we got a slow drip of nitric acid going into the funnel. Just let this react. The trick here is to get that acid in on that material as quickly as possible, but doing it in a safe manner because if we added the nitric acid too quickly, we could cause a boil over and spill hot acid everywhere. And I've set up this little device here, this apparatus, to add the acid slowly like this for me, so I don't have to sit here in front of the fume hood and add small doses of nitric. What I used to do in the past is stand in front of the fume hood and add small doses of nitric and wait for it to calm down and add some more. But with this apparatus, I can carefully control how much nitric goes in, and it's going in continuously for me. All right, got the first 500 milliliter dose in the beaker now. What we'll do here is charge up the funnel again with another 500 milliliters concentrated nitric acid. I've done probably 15 or 20 batches of gold-filled scrap like this, so my experience level isn't real high with this gold-filled scrap. So I'm kind of trying to make this go as smoothly as possible, but I don't have a high level of proficiency with doing gold-filled scrap. All right, turn the funnel off. We're going to refill our funnel now with 500 milliliters concentrated nitric acid going in. All right, that'll be number 2. Let's go ahead and get our flow started again. There we go. And we'll continue to let this flow in slowly. I've got the heating pad on low, and there's heat being generated from the reaction. And right now we've got a whole bunch of hot metal in there, so we got to add this acid real slow or we'll boil it over. That nitric acid delivery apparatus sure does work nicely, and it frees me up to be able to do some other activities rather than have to stand there and add the acid manually. Beaker is about 3/4 full. We've got about 1.1 liters of nitric in the beaker down there now. So what I'm going to do is I'm going to stop adding nitric acid here, and we're going to let this cook off until all the fumes go away. And then what we'll do is we'll decant the fluid out of the beaker and start adding fresh acids. We're probably about 1/3 of the way done here with the nitric addition. It's going to take about 3,600 milliliters to completely dissolve all the base metals out of here. So we'll call this quits for now, adding the nitric, and we'll just let I'm going to crank the heat up a little bit here. We're going to let this completely react until we don't have any more fume production inside this beaker, and that will let us know that our nitric acid has been consumed completely. We started on this video about 7 a.m. and right now it's 9:30 p.m. We've been working on this thing all day, and I've got about 1,100 milliliters of nitric acid in there, and as you can see, I'm kind of running out of room here, headroom. I don't want to be adding any more nitric acid in there because it's too full right now, and it's at the critical point where nitric additions on that hot metal, that beaker full of hot metal, could easily cause a boil over. We're about 2/3 full of liquid there, and I was kind of concerned about the amount of room that we got left in here. But I'm going to make a bold decision here. We're going to continue adding another 500 milliliter dose of nitric acid. Well, I'm going to have to put in about, it's going to take about 3,600 milliliters of concentrated nitric acid to dissolve out all the base metals from this scrap, and I've only got about 1,100 milliliters in there, so I'm going to try to get another 500 milliliter dose going in. That'll put us at about 1,600. Start the flow again, nice and slow here, because we're at a critical point. The metal in the beaker there is real hot, and so we want to watch out adding that nitric too quickly. If we do add it too quickly, we could experience a boil over. So I'm going to go in and start editing the video and let this next 500 milliliter dose go on in. Once most of the metal gets dissolved by the nitric acid, it won't be as critical to add the acid slowly as we progress through the process. Got about 1,600 milliliters of the concentrated nitric in here now. So what I'm going to do, I'll let this boil off until all these fumes clear up. We're going to add some distilled water to it to thin it out, and then I'll turn the heat off. It's been about an hour and 15 minutes since I added that last half a liter of nitric to this. So what we're going to do, we're going to turn the heat off, and I'm going to add some water to this to thin it out a little bit. Distilled water going in. This will help cool it off, plus tend to dilute that concentrated solution there. And we call it a night. Been working on this at 7 a.m. and it's about 12:30 the next day. Alright, that's going to be good enough there. We're going to wrap this up. That will conclude part 1 of the video.